All right, so this is 17.1, problem solving with trigonometry. So we know how to find the area of a right triangle, but not all of our triangles are right triangles. So we need to be able to find the area of a non-right triangle, and we can use trig to help us do so. The area equals 1/2 A times B, A and B are sides, times sine of C, sine of the angle C. The C has to be the side, or the angle that's included between the two sides. So I'm going to kind of show you what that means on this first example. I have this side and this side, so the angle that connects the two sides is right there. That is called the included angle. So when I write this out, this is my A, this is my B, and this is my sine of angle C. So I simply say, I guess if I should write it with the right letter, A equals, can you guys see that? 1/2 3.2 times 4.7 times the sine of 132. And again, from this point, and yes, you must show me the substitution, but from this point, plugging things into your calculators. So substitution must be shown. So when I start simplifying it, I get A equals 7.52 times the sine of 142. You should be checking, and we get 4.63 meters squared as my area of that triangle. So you must show the substitution. I would prefer you to show a little of the simplification of the numbers, just so that if you punch something in your calculator wrong and get the wrong answer, I can always give you some partial. So our second example here, same thing. We're looking at finding the area. This is the included angle because it connects the two sides. So the area equals 1/2 12 times 15 times the sine of angle 34. So when we're simplifying our math and we multiply these values together, we get 90 times the sine of 34. And so when we're completely done, the area ends up being 50.3 millimeters squared. And we found the area. So the area is pretty simple. It's very similar to the formula we're using, 1/2 base times height, but since we don't have a 90-degree triangle, we have to account for the angle that is there. So we're going to look at a word problem. This word problem says that we're solving a right triangle. A shelf extends perpendicular 7 inches from a wall. So here's our shelf going across here. Here's the wall. You want to place a 9-inch brace under the shelf as shown. To the nearest tenth of an inch, how far below the shelf will the brace attach to the wall? So we want to know actually this distance here. So we're looking for this distance here. And then it says to the nearest degree, what angle will the brace make with the shelf? So we're looking for this angle and with the wall. So we're looking actually for 3 pieces of information. Okay? So to find BC first, well, this is a right triangle because quite honestly, nobody wants a saggy shelf. So we can use Pythagorean theorem to find that. This is A, this is B, this is C. So to find BC, because this is C up here, we simply say A squared plus 7 squared equals 9 squared. Remember, this is Pythagorean theorem. A squared plus B squared equals C squared. I don't want an equal sign there. So we're going to simplify it. That's A squared plus 49 equals 81. Subtract the 49 both sides. A squared is equal to, what is that, 32? And then you take the square root of both sides and use your calculator. A is about 5.7 to the nearest tenth of an inch. So it tells you to round it to the tenths. Now, to find the angles. So I know that this is 5.7. This value here, we don't want to use it in our calculations simply because we've rounded it and it's not completely accurate. So when we do our calculations for the angles, we want to use the 7 and the 9. So let's start by finding angle A. This one here. On angle A, this is your adjacent, this is the hypotenuse. So what uses adjacent and hypotenuse? Cosine. So we say the cosine of A is equal to the adjacent 7 divided by the hypotenuse 9. So we have A is equal to the cosine of the inverse, 7 divided by 9. From there, you simply plug things into your calculator, and you get A is equal to, it comes out to be 38.9. It asks us to round it to the nearest degree, so that's approximately 39 degrees for angle A. And then for angle B, same idea. We're over here, but now this is the opposite side. So now we're not going to use adjacent and hypotenuse. We're going to use the opposite and the hypotenuse. So that would be sine of B is equal to 7 over 9. Now you'd think because we're using 7 over 9, we'd get that same value, but we're not going to because we're using a different trig function. Maybe that'll help with the clarity. So we get B is equal to the sine -1 of 7 over 9. And again, you're punching this into your calculator. And we get B to be approximately 51 degrees. Now there's another way we could have gotten B. We should remember that in a triangle, A, B, and C have to add up to 180 degrees. So we could have said angle A plus angle B plus angle C has to equal 180 degrees. We know that angle C is 90 of that. We know that angle A was 39. And we don't know angle B, but we know that they add up to 180. So I can add the 39 plus the 90, and that would give me 129 is equal to 180. And then when I subtract that 129 both sides, I would get angle B equal to 51 degrees. So I've given you two ways of trying to figure out what angle B would be. Now we have one last word problem over here. And I'm going to move this swivel over, even though I know that it will switch over, but I want it to get a little bit closer so you guys can see. Talking about a coordinate plane, we have a triangle ABC has the vertices. Whenever you're given the vertices, please, please, please graph it. It makes it a visual and it makes it so much easier. So we're going to graph -3, 3 for A, so -3, up 3, there's point A. B is at -3, -1. And C is at 4, -1. So I'm going to play connect the dots because I know that I have a triangle. All right. And it wants me to find all the angles and all the sides. So this side is easy because it's perpendicular. I can count. I'm going from 3 to -1. There's 1, 2, 3, 4 units. Going from B to C, I'm going -3 to 4. It's 1, 2, 3, 4, 5, 6, 7 units. Now, I can use Pythagorean theorem or I can use the distance formula. We're going to practice it with the distance formula since we've already used Pythagorean theorem, just to remind you what that is. So if I'm using the distance formula between A and C, I use the coordinates. Remember, it is x2 minus x1 squared plus y2 minus y1 squared, and square root it. So if I name this x1, y1, x2, y2, and I plug my values in. So that gives me 4 minus a -3 quantity squared plus -1 minus 3 quantity squared. So simplifying this down, this double negative becomes a positive, so we get 7 squared. That is -4 squared, and when you square negative, it becomes positive. So that's 49 plus 16, which gives me the square root of 65, which is approximately 8.1, I believe. Oh, where'd we go? Yes, so 8.06. Says the nearest hundredth, not hundred, it should say hundredth. An angle measures the nearest degree. So now, if I want to find my angle measures, well, B is what? 90. So the measure of angle B equals 90 degrees. Now we can choose to find A or C. We're going to use the 4 and the 7, not our estimated value. So angle A, this is the adjacent, this is the opposite. So that's tangent of A equals opposite 7 over 4. So A is equal to the tangent to the -1 of 7 divided by 4. So we end up with measure of angle A equaling, I did not write that correctly, put the equal sign in the wrong spot. Measure of angle A is about 60 degrees is where it rounds off to. Now, you can use adding to 3, or we can actually go find it using trig. I think it's easier to say angle A plus angle B plus angle C has to equal 180. We know that B is 90, A is 60. That means I got to figure out what C is. So it's 150 plus angle C equals 180. That means that angle C must be about 30 degrees rounded. All right, so I know I kind of went through quickly. We'll go over some problems tomorrow. This is all pretty basic of trig. So we'll practice problems tomorrow and go over a few more examples.